Hi, I am Vempati Srinivasulu, Assistant Professor of Chemistry, Nagarjuna Government Degree College, Nalgonda. In the previous classes, we have started carbanions chapter. We have completed two parts, part 1 and part 2. In part 1 and part 2, what we have discussed is a quick recap. What are carbanions? A trivalent carbon with negative charge is called carbanion. Carbanion may be sp3 or sp2 or sp. sp3 hybridized carbanion, generally it is in pyramidal shape. It exhibits sp3 hybridization. Carbanion, how generates? We have discussed different types of generation of carbanions and different types. So what is the stability of, how can we assess the stability of carbanion? So what are the factors stabilizes the carbanion? We have discussed. In the next part, we have discussed acidity of alpha hydrogens, which are linked to electron withdrawing groups. Then we compared different hydrogens acidity with pK values. Then we have discussed what is tautomerism. What are tautomers? What is tautomerization? How a one tautomer is converts into other tautomer. What are tautomers? So we have discussed tautomerization in carbonyl compounds and nitrohydrocarbons and in different classes of compounds in detail. So far we have discussed these things. So in this part we discuss what is, we know already carbanion. So what are the reactions involving in carbanion? So we have different reactions. For example, aldol condensation reaction, benzoin condensation reaction, Cannizzaro reaction, haloform reaction, etc. So in this carbanions 1 part 3, we discuss especially about aldol condensation reaction. So what is aldol condensation reaction? What are the required conditions required to occur aldol condensation reaction? With what is the mechanism of this condensation reaction? What are the compounds which does not exhibit this reaction, and what are the applications, and what is a crossed aldol condensation? All these things we discuss in detail. So let us start. Okay, first of all, what is aldol condensation reaction? Definition. I think we have learned this aldol reaction in intermediate also. So tell me, what is aldol reaction or aldol condensation reaction? The definition is condensation between two molecules of an aldehyde or a ketone to form a beta hydroxy aldehyde or a beta hydroxy ketone is called aldol condensation reaction. So what is the aldol reaction? So aldol reaction occurs in especially carbonyl compounds. So maybe aldehydes or in ketones. So the primary condition of this reaction to occur is the carbonyl compound should contain at least one alpha hydrogen. You know what is alpha hydrogen? We will discuss. So with a carbonyl compound with alpha hydrogens, at least one, they undergo a special type of reaction in which two molecules participates in this reaction by giving a aldol beta hydroxy aldehyde, or in the case of ketones it is give ketone. So generally we call this reaction as aldol condensation reaction. So very important thing is, for example, here we have given an example. So what is this example? You see acetaldehyde. You see this is acetaldehyde, CH3CH4. In presence of base, this is a base, it is base, hydroxide. In presence of base, it is giving a compound like this. So what is this? You see, so this is acetaldehyde. Okay, acetaldehyde is having alpha hydrogens. Where is alpha hydrogens? You see, this is a functional group. This is a carbonyl functional group. The adjacent carbon which is attached to this functional group is called alpha carbon. Oh, this is alpha carbon. The hydrogens attached to the alpha carbon are called alpha hydrogens. So in this case, we have, you have three alpha hydrogens. You see, these three hydrogens are alpha hydrogens. So three hydrogens are there. That's why this reaction exhibits aldol condensation reaction. Okay, so in presence of base, two molecules undergoing this reaction. So condensation means that only addition, combining two molecules by eliminating small molecule like water or ammonia, it gives a corresponding a product that is called condensed product. So in this condensation reaction, we are getting this type of compound. What is this? You see, 4 number carbons, 4. You see, 1, 2, 3, 4 carbons. So we call as butyraldehyde, butanol. So in the second position, we have one OH group, this one. That's why it is 3-hydroxy butyraldehyde, or we call this is beta hydroxy butyraldehyde. You see, this is alpha carbon, this is beta carbon. There is a hydroxy group at beta carbon. That's why it is beta hydroxy butanol, butyraldehyde. So this is generally we call as aldol. Why you are calling aldol? In this compound we have aldehyde group and alcohol group. So aldehyde plus ol means alcohol, aldol. We call as aldol. So this aldol also unstable, easily undergo dehydration reaction. It gives crotonaldehyde, a alpha beta unsaturated carbonyl compound. This is called enones. So what happens? This OH and H goes and a double bond formation takes place. So this is called crotonaldehyde or alpha beta unsaturated aldehyde. We also call enones. So this is a example for what? Aldol reaction. So 2 moles of acetaldehyde undergo condensation reaction in presence of base. It is giving beta hydroxy aldehyde. This is an example for aldol reaction. So next slide. So what are the conditions? So general some points about this aldol reaction. You see, if you see the mechanism of this reaction, all the steps involved in this reaction are reversible in nature. Reversible. Second, there should be base like hydroxide ion in the reaction conditions. So it's a reversible reaction. base is required, hydroxide ion is required to occur this reaction. In this reaction, a specific point, a new CC bond formation takes place. This is a very important one. So when we want a new carbyl methyl group or any other alkyl group, we have to attach a component or a substrate. So generally we use this aldol reaction if it has alpha hydrogen. Okay, so this is one characteristic feature of this reaction. A new CC bond is generated in the product. So one more thing is, if the compound in the substance or in the reactants, if you have no alpha hydrides, no question of aldol reaction. So that means at least one of the reactant should have alpha hydrogen. If a reactant does not have any alpha hydrogen, aldol reaction doesn't proceed. So these are the different characteristic points. For example, in the previous case, acetaldehyde exhibits aldol reaction. Acetone also gives aldol reaction. Why? Because in acetaldehyde we have 3 alpha hydrides, just now we seen. Whereas in the case of acetone we have 6 alpha hydrides. That's why it also exhibits aldol reaction. You see, one more example. This is a trimethyl acetaldehyde. We see a carbon is attached to 3 methyl groups. So acetaldehyde, in the place of hydrogens we have methyl groups. So that's why there is no alpha hydrogen. This is a functional group. It is an alpha carbon. This is alpha carbon. So this alpha carbon doesn't have any hydrogen directly linked to this carbon. That's why we don't have any alpha hydrogen in this compound. What is this compound? Trimethyl acetaldehyde. So that's why this compound doesn't exhibit aldol reaction. Coming to next compound. This is a formaldehyde. Formaldehyde is only one carbon unit. So that's why there is no question of other carbon, alpha carbon. That's why this compound also doesn't exhibit methanol, or formaldehyde doesn't exhibit aldol reaction. Even though in the base reaction, another reaction occurs. We will discuss in the Cannizzaro reaction. Okay, that's different. So benzaldehyde. What is this? Aldehyde group, which is substituted on a benzene in place of hydrogen, is benzaldehyde. So benzaldehyde also doesn't have any alpha hydride. You see, this is a functional group carbon. So this carbon is alpha carbon. So alpha carbon, no alpha hydrogen. There is no hydrogen. That's why this compound, what is this? Benzaldehyde also doesn't exhibit aldol reaction. Coming to next example, trichloroacetaldehyde, chloral, trichloroethanol, all trichloroacetal. All these 3 hydrogens are replaced by chlorines. That's why we call as trichloroacetaldehyde. We call as chloral. So chloral also doesn't have any alpha hydrogen. This is a functional group carbon. It's alpha carbon. So this alpha carbon doesn't have any hydrogen. That's why this compound also doesn't exhibit aldol reaction. So these are the different. One more example. It's a ketone actually. So in this ketone, this is a ketochromyl group. We have 2 alpha carbons. One is this one is this one. So these 2 alpha carbons doesn't have hydrogens. This is the methyl group. This is also methyl group. This is methyl group. So methyl group, methyl group. So hexamethyl acetone. This is a name of the compound, or otherwise 1, 2, 3 pentanone. So 2,4-dimethyl 2,2,4,4 tetramethyl butanone, compound IUPAC name. So this compound also doesn't have any alpha hydrogen. There are beta hydrogens, but we require alpha hydrogens. That's why this compound also doesn't exhibit aldol reaction. So what we learned is to occur aldol condensation reaction, there should be alpha hydrogens in the compound substrate. And one more thing, base OH minus should be present. A base, it should be present. In place of base only this reaction occurs. So in general, in the presence of base, carbonyl compounds containing alpha hydrogens undergo a special type of condensation reaction by giving beta hydroxy carbonyl compound, maybe aldehyde or ketone. So this compound is called as aldol in the case of aldehydes, ketol in the place of ketones. That's why this reaction is called aldol reaction. What is the mechanism? In the previous slide, we have observed a reaction. Acetaldehyde, when it was of base, it gives aldol. What is this? Beta hydroxy butyl. How it forms? So what is the mechanism? So how a reactant is proceeding, in how many steps? Stepwise description of all steps involved in the reaction from starting reactant to end product. So description of all these steps are called mechanism. So in this mechanism, aldol mechanism, aldol reaction, so we have 3 steps. In the step 1, what happens? You see, this is acetaldehyde, CH3CHO. This acetaldehyde, in place of base hydroxide, it abstracts one hydrogen as a proton. Why proton? So this bond dissociates unequally. Why unequally? This carbonyl group is electron withdrawing group. That's why this carbon attracts electron, this CC bond, from this CC bond. So this carbon becomes electropositive. That's why this attracts this bond electrons from hydrogen. That's why this hydrogen goes as H plus, which is attracts this hydroxide. That's why a hydrogen is lost as H plus to hydroxide, forming a special carbon intermediate. That is called, what we call is carbanion. We discussed in the previous class. It is a carbanion. This is a carbanion. This is a why? Because this is having minus charge. So in the first step, carbanion generates. This carbanion is stabilized by resonance. What is resonance? We know electron, due to electron delocalization, there is a formation of more number of structures. We call it as resonance structures. The phenomenon is called resonance. Due to resonance, energy decreases, system stabilizes. So how we, so this electron pair minus charge moves here. At the same time, this electron bond pair towards, due to this electron delocalization, we will get a special type of ion. It's called enone. What we call is enolate ion. Enolate ion. Double bond is there, O minus is there. It is called enolate. You see, specific ion, you have to note it. So it is stabilized. That's why it is stable. So in the first step, stable carbanion generation takes place. It's the first step. In the coming to the second step. What is second step? This carbanion, which one? This carbanion attacks another carbonyl group in another molecule. It is electropositive center. This carbon has plus charge. Because of oxygen, it acts as electrophilic center. It is a nucleophile. We know this is a nucleophile. So nucleophile generally attacks an electrophilic center. This electrophilic center. That's why a new bond formation takes place. You see, and this is a new bond. So this is a new bond. So carbanion attached to the carbonyl carbon. So is the second step. Okay. So in the second step, what is happening? Carbanion generated in the first step is attacking on carbonyl carbon. So generating a new ion. It is second step. In the third step, what happens? Step 3. This O minus charge, ion with O minus charge, abstracts proton from water or acid. Water. Why water? In the previous case, hydroxide ion attracted one hydrogen proton. It formed water. From that water, this O minus charge abstracts a proton from water by giving this type of compound, You see, this is a okay. This is compound. Okay, this is, what is this? It is a aldehyde, beta hydroxyaldehyde. This is the product. At the same time, our catalyst or hydroxide are regenerated. So this is the mechanism of I think finally what happens in this compound, beta hydroxyaldehyde is unstable when it lasts, and that means relatively when it heated, some amount of energy is applied, this hydroxide and H goes as water. You see, loss of water, it is giving a alpha beta. This is, you see, this is alpha beta compound. This double bond is there, this is a carbon compound is there. It is enones, we call as this enones, alpha beta unsaturated compound. So this compound is relatively more stable than this compound. You see, when we compare these two compounds, this is more stable. That's why this compound easily undergo dehydration reaction by giving alpha beta unsaturated carbonyl compound. This is the mechanism of aldol reaction. Aldol reaction, 3 steps. We observe the mechanism. We have 3 steps. In the first step, carbanion generation takes place. It is stabilized by resonance due to formation of enolate ion. In the second step, this enolate ion or carbanion attacks another carbonyl group in another molecule. It forms an ion, O minus ion, a ion. In the final stage, this ion abstracts a proton and undergo dehydration reaction by giving alpha beta unsaturated carbonyl compound, which what we call is aldol. This is the mechanism of aldol reaction. So what are the some more points about aldol reaction or ketone reaction? So for example, we will see the ketone. This is a ketone. You see, this is acetone, CH3COCH3, acetone. In place of sodium hydroxide base, it is giving a type of compound we call as ketone. So what is this compound? Name of the compound is 1, 2, 3, 4, 4 hydroxy, 2 pentanone, 4 methyl, 1, 2, 3, 4, 5. So 4 hydroxy, 4 methyl, 2 pentanone, what we call is ketone. So this is also one example for this aldol type of reaction. So this is a carbonyl compound with alpha hydrogens, 6 alpha hydrogens, 1 alpha carbon, 1 alpha, 2 alpha carbons, so 6 hydrogens. So this has having alpha hydrogens. So this compound in place of base, it is giving a ketone. So when we compare to acetaldehyde reaction, this reaction is slow. This reaction favors backward when we compare to acetaldehyde. In the case of acetaldehyde, reaction produces a forward reaction. Why? So this is a plus I group. Methyl group is plus I group, electron releasing group. Due to plus I effect or hyperconjugation, it releases electron. Thereby, the carbanion generated is unstable. So that's why we can say one thing. So this aldol reaction is facilitated by minus I groups. Minus I group, nitro, chloro, or formyl, or any nitro. All these things, all these groups are act as minus I groups. These minus I groups facilitates, boosts, or favors the reaction to occur. Reaction towards left side, right side. That's why acetone, when we compare to acetone and acetaldehyde reaction, in aldol reaction, it occurs very fast than acetone. Okay. So the one of the drawback in this reaction is we get a mixture of the compounds. Aldol plus cyclic hemiacetal of a compound we get. This is one of the drawbacks of this reaction. So one more example. So this is what is this? Propanaldehyde, 3 carbon compound. You see 1, 2, 3. So propane, the aldehyde is there, propanol. So this propanol in presence of base, In presence of base, it is not given. In the presence of base, it proceeds to give a compound like this one. You see this one. What is this? Oh, numbering. You have to give numbering from here. 1, 2, 3, 4, 5. 5 carbon means penta. Already got pentanol. So it is in the second place we have methyl group. So 2-methyl. Okay, 1, 2, 3. 3-hydroxy. 2-methyl, 3-hydroxy pentanol. The IUPAC of this compound is this one. So this is also aldol. Why aldol? So this is the formyl group. The alpha group, beta carbon. So beta carbon, we have beta hydroxy carbonyl compounds. Generally, beta hydroxy carbonyl compounds will get the products. That's why this is another form of aldol. So propionaldehyde also proceeds aldol reaction because of having these alpha hydrogens. So two molecules of propionaldehyde undergo reaction by giving this one. So finally it loses one water molecule because this in vicinal we have hydroxy group and H group. So easily undergo water molecule by giving this type of compound. When we compare, this compound is more stable than this. What is the justification? What is the reason? So when we compare this one and this one, this is more stable. Why? Because we have enone structure. So double bond is linked to a carbonyl group. You see, a double bond is linked to one carbonyl group we call as enones. So this is a double bond, two double bonds in conjugation. So this type of systems are generally more stable due to resonance structures, electron deregulation. That's why when we compare these two compounds, this one, this is more stable. That's why the reaction proceeds in this direction, the more product is formed. So this is one example for aldol reaction. Propionaldehyde also, because of having alpha hydrogens, it gives aldol reaction. Next slide. Okay, one more example. You see, this is a cyclohexanone. This one is cyclohexanone. Two molecules of cyclohexanone undergo reaction in presence of base, giving this type of hexocyclic double bonded compound. Two rings are attached to a double bond with a double bond. This is called hexocyclic double bond is there. This is hexocyclic double bond. So cyclohexanone in presence of base, it undergo aldol reaction. Why aldol reaction? How can you say? So we have a carbonyl compound. What is the conditions? It's a carbonyl compound. It has 4 alpha hydrogens. This one alpha carbon, this one alpha carbon. So a carbonyl compound, that means ketone. It has alpha hydrogens. The one more thing is we have base in reaction conditions. So in the presence of base, carbonyl compounds exhibits aldol reaction. What we just know. So it is by giving this type of compound. It is also enone is there. Double bond is there. Carbonyl this double bond and carbonyl will be attached by separated by double bond, single bond. So double bond, single bond, a keto group. It's a enone structure is there. That's why it is stable. So what is the mechanism? You see the mechanism. So first hydroxide abstracts one of the alpha hydrogens. We have 4 alpha hydrogens. Here 2, here 2. So one of the alpha hydrogens lost as proton to the hydroxide by converting to water. One carbon ion is generated. This is a carbon ion. So this carbon ion is stabilized by resonance by forming enolate ion. This is enolate ion. You see, this is the enolate ion. It is stabilized. Then this stable carbon ion attacks carbonyl group of another cyclohexanone molecule. You see, this is a carbon ion. It is a nucleophilic center. It attacked on carbonyl. Why here it is an electrophilic center? Because of oxygen electronegativity, it loses electrons. That's why it acts as electrophilic center. So that's why this carbon ion attacks on carbonyl carbon by forming a ion with O- charge. This on abstraction of one proton from water or acid, it forms this type of compound. This type of compound. You see this type of compound. This on losing water molecule OH and H, by losing one water molecule, it is giving the product. It is like a ketone. Okay, this is the mechanism for this reaction. So anyhow, this cyclohexanone, because of having alpha hydrogens, it is exhibiting aldol reaction. Okay, there is a mixed aldol. That means if you observe this reaction, this is a specific reaction. You see carefully, what is this reaction? One acetaldehyde, one ketone, acetone. In presence of base, this means aldol reaction. What we are getting? We are getting 4 types of products. 1, 2, 3, 4. You see carefully. 1, 2, 3, and 4. 4. So we get a mixture of these 4 products. What is the reason? What is the justification? What is the explanation? So you see, we have 2 carbonyl compounds. One is acetaldehyde. With the 2 molecules of acetaldehyde, we will get this compound. You see, this is a, what is this? This is a aldol, 4-hydroxybutyrolate. So one is explained. So you see ketone. This is a ketone. This is a ketone. So ketone is giving this type of compound from this compound. So from two molecules of ketone with carbanion divided by acetone is forming. We expect this 2 from this acetone. So from 2 molecules of acetone, by combining by condensation reaction, it is giving 2. So 1 and 2 are explained by one from acetaldehyde, another from acetone. So this is okay. So what about this one? Third product. You see number 3. You see, this is the name of the compound is, you see, 1, 2, 3, 4. So 3-methyl 3-hydroxybutyrolate. So what is happening here? You observe carefully. So this is, we are expecting this product from acetaldehyde and acetone. So in the first, you see the mechanism of this compound, this reaction, which is formed this product. So first carbanion generated from acetaldehyde. This carbon attacked on acetone. So acetone acts as a electrophilic center. Acetaldehyde generates carbanion. So between these 2 reacting molecules, we expect this type of compound. I think you understand. So what about this one, 4th one? You see, acetone formed carbanion. Acetone formed carbanion. This acetone attacked acetaldehyde. So this is a 4th product. So we have getting different possible products we are getting. So out of these, we'll expect more these 2 only. 1 and this one. 1 and 3 we'll expect more. Why? Because in these 2 cases, we have acetaldehyde carbanion. So which is more stable than acetone carbanion. Why? Because acetone carbanion has unstable, somehow unstable. Okay, stability is more. Okay, so this is a reason. So in this case, whenever acetaldehyde and acetone are mixed, in this mixture, when react with hydroxidane, we expect these 4 types of products. So this is a mixed aldol reaction. Next, crossed aldol reaction. One more type of aldol reaction. So in this case, 2 different molecules of aldehyde or ketone combine to form beta hydroxyaldehyde or beta hydroxyketone. This reaction is called crossed aldol condensation reaction. In the previous case, we discussed, so 2 products, 1, 2, 3, 4 we got. 1, 2 are normal reaction. 3 and 4 reactions of products are due to crossed aldol reaction. So what is crossed aldol reaction? What is the mechanism? We will discuss in the detail in this part. There must be, we know, to occur aldol condensation, we should have a carbonyl compound with at least one alpha hydrogen and a base. So you see one example, You see, we see one example for this crossed aldol reaction. What is crossed aldol reaction? This reaction also in between two types of aldehydes. Two ketones are one aldehyde or one ketone. Two carbonyl compounds. One is having alpha hydrogen. You see, acetaldehyde is having alpha hydrogen, but benzaldehyde doesn't have any alpha hydrogen. So in between these two, we expect a crossed aldol reaction. What is happening? If you see the mechanism, we'll see the next session slide. Okay, so this is type of crossed. This is one example. So reaction between benzaldehyde and acetaldehyde in place of base, it is giving this type of reaction, this product. You see, what is the product? You see, name of the compound. Okay, this one is a reaction product of between acetaldehyde and benzaldehyde. So name is 1, 2, 3. So 1, 2, 3. 3 means propanol. Aldehyde means propanaldehyde. So in that 1 to 3rd place, hydroxy phenyl group is there. So 3 hydroxy, 3 phenyl propanol. So this is the reaction product due to reaction between benzaldehyde and acetaldehyde. It is also called a crossed aldol reaction. Why you are calling crossed aldol reaction? This reaction is in between two types of aldehydes. One aldehyde with alpha hydrogen, another aldehyde without alpha hydrogen. So this product easily undergo dehydration reaction by giving cinnamaldehyde. This is called cinnamaldehyde. This is cinnamaldehyde. It is also an alpha beta unsaturated carbonyl compound. It's aromatic compound. It is called cinnamaldehyde. So reaction between benzaldehyde and acetaldehyde in basic condition in terms of hydroxide, it is giving cinnamaldehyde. It's an example for crossed aldol reaction. One more example. You see, acetaldehyde when react with the formaldehyde in terms of sodium hydroxide like base, it is giving this type of compound. Actually, this is one alpha beta unsaturated carbonyl compound. Okay, you see what is happening here. Acetaldehyde, we know alpha hydrogens. Formaldehyde, we don't have any alpha hydrogens. Whenever these two get mixed, this mixture in presence of hydroxide ion, strong base like NaOH, it is giving this type of compound. On dehydration reaction, we are getting this compound. What is this compound? Propanol. So it's a propanol actually, but at second position we have double bond. So 2 propanol, 2 ene, propanol 2 ene. So we are getting this type of product. So what is the reason? What is the explanation? So to explain well, we have to understand the mechanism of this reaction. So we'll take this reaction, first reaction as for mechanism for crossed aldol reaction. You see, acetaldehyde. Acetaldehyde, we are explaining mechanism for crossed aldol reaction between acetaldehyde and benzaldehyde. So in the first step, what happens in presence of base abstract proton from acetaldehyde. Why? Because benzaldehyde doesn't have any alpha hydrogen. Only acetaldehyde has alpha hydrogen. So this alpha hydrogen is lost as proton to base by forming a carbanion. This one. This is a carbanion. This is a carbanion. This carbanion is stabilized by resonance in formation of enolate ion. So it is resonance stabilized carbanion. So in the first step, we have it in the first step, carbanion formed, generated and stabilized by resonance. That means stable carbanion formed. In the second step, what happens? There is a benzaldehyde in the vicinity of this carbanion. This carbanion or enolate ion attacks. The electron pair comes here. This bond pair attacks here. That means this carbon is electronucleophilic center. So this carbon attacks this carbon, which is electrophilic in nature. So by forming this type of ion, this on abstraction from proton, attracting proton from water, it forms this type of ion, this type of molecule, hydroxy compound. On dehydration, we know on dehydration, water molecule, by losing water molecule, Okay, water molecule, it forming this type of compound, cinnamaldehyde. So this is a mechanism. So in the first step, what is happening here is, in the first step where a carbanion is generating. In the second step, this carbanion attacking benzaldehyde. In the third step, by abstracting proton from water and followed by dehydration reaction, we are getting our product cinnamaldehyde. So this is a explanation for crossed aldol reaction. So we have studied the carbonyl compound should have alpha hydrogen, but in this case, in between two carbonyl compounds, whenever one should have at least alpha hydrogen, then only reaction takes place. So this is a crossed aldol reaction. Coming to the applications, already we discussed these applications. In this aldol reaction, a new carbon-carbon bond formation takes place. To synthesize large molecules from small molecules, this reaction is used in so many industries, synthetic chemistry. Generally, this synthesis for insect repellents, we use this reaction. It is also used in biological synthesis process, synthetic process. These are the different applications. So this is about aldol reaction and crossed aldol reactions. So what we have learned today, quick recap. So what is an aldol reaction? Condensation reaction between two carbonyl compounds, at least with one alpha hydrogen, by giving beta hydroxy carbonyl compound. This condensation reaction is called aldol or ketol condensation reaction. Generally we call as aldol. So these carbonyl compounds, aldehydes or ketones, those who have alpha hydrogens exhibit this type of reaction. The condition is in presence of base, hydroxide should be there. So in presence of hydroxide, reaction proceeds. All these reactions involved in this reaction is reversible reaction. This reaction is favorable by minus I groups. Why? Because formed in the mechanism, when you see the mechanism, a carbanion generates. When hydroxide abstracts proton from carbonyl compound, where there is a carbanion generates, this carbanion is stabilized by resonance. Whenever carbanion is attached to minus I groups, more stable. That's why minus I group C favors this reaction towards right side, whereas plus I groups destabilize the carbanion. That's why not favors the reaction. That's why, okay. So minus I groups is favor the reaction. Then come mechanism. We explained mechanism. In the first step, we have carbanion generation. In the second step, this carbanion attack the carbonyl group. In the final step, it abstracts proton from water and losing water molecule. We are getting stable a alpha beta unsaturated carbonyl compound. In the place of aldehydes, we call as aldol. In the case of ketones, we call as ketone. Okay. Then we explained with different examples. Okay. Then we have taken acetaldehyde and propanaldehyde and explained this reaction, and also with cyclohexanone. Then coming to the crossed aldol reaction, it's a reaction between two types of carbonyl compounds, maybe aldehyde or ketone, or two different aldehydes, or two different ketones, but at least one is having alpha hydrogen, other may don't have alpha hydrogen. For example, acetaldehyde and benzaldehyde, or acetaldehyde and formaldehyde. So in between these two, we expect a crossed aldol reaction. Finally, we discussed different synthetic applications of carbonyl compounds. This is today's class. Thank you very much. Thank you very much.